Hello everyone and welcome to day 12 of Kaggle's 30 days of machine learning challenge, and today we are going to learn about missing value imputation. So this is part 1 of day 12. Part 2 is a separate video, and in this video we are going to learn about missing value imputation, and we assume that you have gone through the last 11 days, earned yourself a certificate in Python and also an intro to machine learning. Today we are starting intermediate machine learning. So this is a 3-day course, and there's a lot to learn. So missing values, what are missing values? So the data doesn't always have, the data that you will be dealing with as a data scientist doesn't always have all the known values. So if you remember the Titanic dataset, there was a column called survived, which was whether a person survived or not. And then you had the sex column, you have P class column, you have age column. Now, if it's not possible for the person who gathered the data, some values can be missing. So if it's not possible for the person who gathered the data to collect all the values required to make this data dense, then some values are missing. So, like for age, maybe we don't have the age information for all the passengers in Titanic. So some values will be missing. So now what can you do with the columns which have missing values? There are many different approaches on how you can handle missing values when building a machine learning model. And it also depends on how good your validation, how good of a validation system you build to examine which technique fits the best. So there is no like rule of thumb. You have to try different approaches and see which is the best approach. So one simple thing would be to just remove this column. Remove it. Now, when you remove it, you don't have a lot of data, and you're dropping a column which might be useful. So, like if you have tens of thousands of samples, then probably you can drop it. But any new feature can bring a lot of new potentially useful information, and that's why it's not advisable to drop the columns all the time. So yeah, that's your first approach. Drop missing value column, drop columns with missing values. So drop columns with missing values. The second one is interesting. You can impute missing values. Impute missing values. So now the column that we are talking about is, let's say, the age column, and you have some ages like 10, 30, 50. So this is some random data, 25. Then you have a missing value, okay, and then you have I don't know, 40. So what is the value of this missing data point will be? You can have more missing values. So one more x. What is the value of these two missing values? So a very simple way to do this would be to take these values and calculate their mean. So this is one of the techniques. The other way that you can do, and mean will be substituted at both places to all missing values. Another technique would be to do median. So this is another way of imputing missing values. So one way would be to do mean, another way would be to do median. Okay. There is a third way of imputing missing values, and that's called take the most occurring value, most frequent. Most frequent. So let's say you have a missing value in the column P class, so that's passenger class column. So, and that's categorical. So passengers can be first class, second class, third class, like that. Let's say they are like that. So you have some missing values. You have passengers in first class, second class, third class, and how would you fill this value now? Now this is a categorical data. It's not, uh, it looks like int, obviously, but it's categorical, right? So these are not numbers. So these are classes. So here, the missing value can be imputed by what is the most occurring, most common value in this data set. So this is 3. So I impute x as 3. So most frequent. Um, and in the tutorial, they have also shown you like there is one more way in which you can add this information about missing value. So let's say you have imputed, but you still can add this, add a new feature to your data set that says, okay, this value was imputed. So let me copy this thing and let's put it here. So this was my column with age. Okay, and now I have imputed this missing value. So the values here are imputed. So by mean. So just calculate the mean and impute them. And this is my age feature. So now I can add another feature, and this feature will be age underscore missing. That will consist of true or false. False, 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 true, false, true. So now this will take care of when you're building the model, it will also know if this missing value, if this value which is here, the imputed value, was it missing or not. So this way you provide more information to your machine learning model about the missing values. Now, there are also ways to handle missing values in such a way that your model knows it's missing without adding a new column. So if you're dealing with models like random forest or decision trees or any decision tree based model, any tree based model, what you can do is here I have the age column. So let's copy the age column again and see what can we do here. So like here is the age column, and what can we do is we know that age cannot be negative, right? So we just write -1. And now the model doesn't understand age. It's just looking at the number, right? But it will know that these values are special and they occur maybe frequently, maybe not so frequently, but these are special values. Everything else is positive, but these are negative, and it will be able to figure out if that this is a missing value. So you don't have to do anything, just add -1. If it's like a numerical column that can have only positive integers. If it's like a P class column, so different classes, right? Now I don't remember what the classes were. First class, second class, third class, let's say some more. X, 3, 3. So now here what you can do, here you can also add a class 0, which doesn't exist, or even -1, which doesn't exist in the data. And this way it knows that these are missing values. Okay, so now you always compute the imputation from the training set and you apply the same imputation to the test set. So if you know that in test set you will have 0 as B class, then you don't use this imputation. You can use -1. And now we can look at the tutorial. So in the tutorial, they have described the same things that I told you. I told you a little bit more than what's written in the tutorial. So now what we do is we read the Melbourne housing price dataset and we do some stuff. So let's just first read the data. So now we have the data. So if I check data.columns, it has all the columns including price, and that's the column that we will be predicting. And now here I can write data.drop price x is equal to 1. So now this drops the price column from the data frame and creates a new data frame called MELB predictors. So if I write MLB predictors dot columns, what do I get? I get all the columns except the price column. So here I don't have the price column, and these are my predictor features, right? These are my predictors that I will be using. So now what I can do is I can, okay, I don't do it here. So what I can do now is I can use select D types. So if you go through all columns, so for column in melb underscore predictors or data dot predictors, let's go to data. For column in data, so in the data frame, data dot columns, let's print data column dot d type and the column name itself. So column comma data d type column. So suburb is an object, address is an object, rooms is int64, type is object, price is float 64. So you see it's giving you the d types of all the different columns that are present in the data. So what this means is mostly the columns which have strings in it will be marked as objects. So we can just do data frame dot select d types, which is another useful pandas function, and then we can write exclude the d types, which is a list, and inside that we can write object. So it will exclude all the object d types. So if I run this part, now my columns are reduced to just a few columns, which are integer or float columns. So see it like this. And they have missing values. So you can see some missing values here, but if you do data.describe, you will find there are probably many missing values. So now what we do is we split the data into training and validation set. And with random state 0, our test size is 0.2. So that's another argument, new argument that you learned today. And that's 20% of the data goes to validation set, 80% of the data goes to training set. And we run this. So now it creates new data frames, xtrain, xvalid, and ytrain, yvalid, which are these are series, but these are data frames which have 80% of the data is in train and 20% data is in valid. Okay. And now we create a function that will help us measure the mean absolute error given the data sets. So I will provide xtrain, xvalid, ytrain, and yvalid in this function called score dataset function. Run the model, run any model. So here we are running random forest regressor with just 10 estimators. Fit the model, predict from the model, and on the validation set and calculate the mean absolute error. So I hope you understand this function and you have seen this in previous videos. Okay, so now as I mentioned earlier, you have to try out different approaches for dealing with missing values and find out what's the best for your dataset. So now here, what we are doing is we are trying to find the columns which have missing values. So I write for all columns in xtrain.columns, if my xtrain column dot is null, so that's also a function, and if you do dot any, so it will be true if any of the values in is null is true. So one of the very simple ways of doing this will be to just run it individually if you want to know more about it. So xtrain.head, and let's see, rooms. So I will start with rooms. So rooms is null, and it gives you the series which can be true or false. So if it's false, so this value is not null, this value is not null, this value is not null. And here I can do sum, and sum will be more than one if one or more if there is at least one missing value. So it doesn't have any missing values. Now I can do the same for building area. So building area, let's see, it has 5,156 missing values. And if it has 5,000 156 missing values, I can do dot any, and this will give me true or false. So it has missing values, that's why this is true. If I just do rooms here, this will be false. So that's what is happening in this list comprehensions. For every column in xtrain.columns, if the column has any missing value, put it in this new list and call it calls with missing. Okay. So now we have columns with missing values in it, and now we drop those columns from the dataset and see what our MAE is. So we drop those columns from xtrain. We also drop those columns from x_valid, and our MAE is 183,000. Okay, the second thing that we will do is we will impute the values, and for imputing we will use scikit-learn, and we import from scikit-learn.impute, impute simple imputer. Now how this works, you can go to the scikit-learn documentation. There's so many details provided there. You can just run the code on your own and see how it all works. So let's take this example, and I will put the example here. So data, so let's call this one data, and imputer.fit data, and we can call it train data, and we can call this test_data. Okay, so what is happening here? So we don't do anything. We first defined a numpy array or a list of lists, and we can do np.array. So now it becomes your numpy array, and let's print this train_data, and it's like this. So you have 1, then you have np.nan is your missing value, nan 7 2 3 6. So these are 2 features and 3 rows, 2 columns, 3 rows. Then we initialize imputer. So we do simple imputer and then say what our missing values are. Here in our case, the missing values are nan, and we will fill them with the mean strategy. Okay, so now we fit the imputer on train_data. So my imputer is fit. And now if I want to transform the train data to another data set which doesn't have missing values, what I will do is I will just do imp.transform train_data. So now here this value nan should be 4. 7 plus 1 divided by 2, right? And that is 4. And if I have a new data set again, so now I have test data, and my imputer is already fitted. It's already trained. So in scikit-learn, it's always .fit, .predict, .transform, .predict probability. But right now you have fit and transform and predict. So if you have test data, you can just do imp.transform x and test_data, and it's going to say, okay, in the train data, the mean value for first column was 4, so I fill this one with 4, and the mean value for second column was 3.6667, whatever, and I fill it with this value. Okay, so it calculates mean of each column without the missing value, and it just fills the value. Makes our job easy. And similarly, we can also do median. Okay, and now it fills with median value. Okay, so now in our case, we have my imputer is simple imputer. We don't provide anything, so it works with default values. I guess those are mean, and so if I keep this, go to the documentation of simple imputer, I will find the missing value default is nan and strategy is mean. Okay, great. So here default is nan and strategy is mean. So now I calculate imputed xtrain and imputed xvalid using So see, we are fitting and transforming the training data directly, but for the validation data, we are using only dot transform. So another way of doing this would be to do my underscore imputer dot fit x underscore train. So we are always fitting on the training data, and for validation data, we are doing dot transform. If we do fit underscore transform here, or if we fit on validation data, it's going to learn about validation data, and it's not going to use training data to fill missing values inside the validation data. So this is something you have to take care of. Okay. Uh, Now here, okay, there are a few more things. Now if you see the imputed values, impute imputed x underscore train. So now what it did was it was a data frame. X train was a data frame, but it changed the column names from 0 to something. So that's what it's saying here, that now you must put back the columns. So the order is going to be the same. So I can just do imputed x train dot columns, and here I can provide a list of values, which is x train dot column, and same for xvalid. And now I calculate the MAE again, and I get 178,000, which is lower than the previous one. Okay. So here it says approach to perform better on this data set. So yeah, that's what you have to do. You have to figure out these approaches on your own and see which one fits the best. Now, they say that there is another approach, an extension to imputation. And in this, what we do is we add a new column, and that new column has only true or false values in it. So we go through all columns with missing values, and we add a new column to the data set. If so, this column underscore was missing, so this will be the new column name. And here they have also they have created a copy of the dataset. So you can create a copy of the dataset. So if you change anything in here, it doesn't change anything in here. So that's what they have done. And once you have created these new columns, you use the imputation again to fill the missing values and put the columns back again and calculate the score on the new approach. And this gives you 178,927. So 178,166. And this is not a good approach for this data set, at least. Okay, so now it says, why did the imputation performed better than dropping the columns? So the training data has 10,000 something and 12 features. 3 columns contain missing data. So there are 3 columns that contain missing data. For each column, less than half of the entries are missing. Thus, dropping the columns remove a lot of useful information. And so it makes sense to apply imputation instead. Great, right? We can do a lot of other different cool things here. So now I also told you about another type of imputation in which you do strategy equal to most frequent, right? And if your columns are in are object columns, you can apply this strategy. Okay, but we are not looking at that example in this video today, or maybe we will in the exercise, who knows. Okay, so now it's giving you the number of missing values in each column. So car has 49 missing values, building area 5156, year built 4307. So you can also this is the way I showed you before. Okay, awesome. And that's why we should always try imputing missing values rather than just dropping the column all the time. And now we can do the exercise. So we also have exercise for the intro part, but so here we don't have anything. It's pretty easy. It's just intro. So go through it. It says what you're going to learn, and you're going to learn a lot of things. And here we can just quickly do the intro exercise before doing the missing value exercise. So it's like you have already done all these things before, so you don't have to worry about learning something new because you have already followed the last 11 days. So here we have the train data, we have the test data, and this is the house price regression competition data. And we select some features. And yeah, here we are using dot copy. If you don't want to use, I think that should also be fine, at least for this example. But it's about learning something new. And then see what are the values we have for training. So these are my training features. And now we create a random forest regressor. So we create 5 different models with different criterion, different min sample split, different depth, different estimators, and we put them in a list. Okay. So this is also something that I've shown you before. We just did it manually, and here they have defined, we tried each and every configuration manually, and we didn't try so many, but yeah, here you can try 5 models or 10 different models. Okay, so we just defined these models. And now what we will do is we write a function that takes a model and fits it on a given training set. So training and training targets, and makes predictions on the validation set and returns the mean absolute error on the validation set. So we go through each and every model here. And here you can also do for I comma model, in enumerate models. So now you can do it like this. So I will be the index and model will be the model from the model list, and it's working the same way. So let's run this. So now it's training 5 different models and giving you MAE from 5 different models. So now there is one model with the lowest MAE, and that's model 3. So here it's saying what is the best model. So use the above result to fill in the line below which model is the best model. So here we know that looking at this data, model underscore 3 is the best model. And that's it. And now you generate the test predictions. So create a random forest model with a variable name my model. So the third one was the best one. So we take this one and we paste it here. And now we train our model. Okay, so this is just the definition of the model. So we define the model, and that's all you have to do in this exercise. Now you can also do your model.fit and predict on the test set, generate a submission file and submit to the competition and see what rank you get. So let's see what rank we get. So we have generated the output file. So here is my output.head, and let's go to the competition and download the file. Let's download the file from here. So we will just be uploading the file. So here is download button, and it downloads the file for me. So now I can just go to the competition, click on submit predictions and upload the file. So I have to find the submission, and here is my submission file. And let's upload and see what result we get. Okay, too fast. So we get 20998. So which is not an improvement to our best score because we already did something really good in the last video. So take a look at that. And okay, so that's it. That's for the intro exercise, and we can now safely move to the other exercise, which is the missing value exercise. Okay, let's run the first cell without thinking because that's only for setting up the exercise. And in the next one, what's happening here? We import pandas for reading the files, maybe, and we import train test split for splitting our data into training and validation, training or test set. So everything happening here seems to be same as before, except this line, hopefully. So a lot of pandas operations have in place. So if you do in place equal to true, which is by default it's false. If you do in place equal to true, you don't have to write x underscore full equal to this. So if you do it this way, you have to write it this, like in place equal to false. Okay, remove rows with missing target, separate targets from predictors. So now axis is 0, so we drop NA, we use drop NA, x is 0, so it's removing the rows with missing target. And in the next one, we have the y, so the target variable, and from the full data, we also drop the sale price column in place. So we just remove that column. We selected only those columns without object D type from the training data, just like in the previous one, the tutorial. And we split the data into training and validation sets. So let's see what our training data looks like now. So it's like this. And now it says do some prelim investigation, run the cell below without changes. Okay, let's run and see what's happening. So it's printing xtrain.shape. So these are my training samples, and these are my training features, and missing value count by column. So in every column, there are 3 columns with missing values, 212 in this column, 6 in this, 58 in this. So we can try to do some imputation. So now fill in the line below how many rows are there in the training data. So we can actually just take a look 1168 and write 1168 here, or we can also do it programmatically. So we can write x.shape 0. So number of columns with missing values, number of columns with missing values. So that will be, just take this one, there are 3, and write the length of this. And fill in the blanks how many missing entries are contained in all of the training data. So the total number of missing values. So you can do this, and take a sum, right? Or if we print this, let's see what we get. Okay, so this gives all the columns with the missing values, and if you do dot values, you get all the values, and you can just take the sum, and this will give you the total number of missing values, and you can add here. So yeah, there are many different ways of doing things, and why do you want to do it manually when you can do it programmatically? It's always going to be correct. Considering the answer server, what do you think is most likely approach dealing with the missing values? Maybe it's imputation, because we're learning about imputation. Okay. Okay, yeah, it says that dropping column will unlikely yield good results. Okay, so that's why we impute. So we again create a function, score dataset function with an estimators 100, random state 0. This is just scoring our datasets on different imputation strategies again. So drop columns with missing values. In this step, you will process pre-process data in xtrain, xvalid to remove columns with missing values, set the processed data frames to reduced xtrain and reduced xvalid. Get the names of the columns with missing values. So how to get the names of the column with missing values? You have already done that so many times. So I think it was in the tutorial. So let's see. Missing value columns. It will be C for C in x underscore train dot columns if x underscore train C dot is null dot na. So that should give me the missing value column. So print missing value underscore columns. X is not defined. Okay, let's remove this. Okay, where is X coming from? Okay, this should be C. So these are the missing values, and now we have to do reduced X train. So reduced X train will be X underscore train dot drop the column names. So missing value columns axis equal to 1. So this will drop all the columns which are missing from the training set, and same we do for the validation set. Okay, so this is done. And now run the next cell to see how these data sets perform on your model. So we have dropped columns, and now it's giving us MAE of 17837. Now we do imputation. So imputation. So here you have to start with the imputation. So you can see, so you can say IMP equal to simple imputer. You don't have to provide any arguments if you don't want to provide any arguments here. So it's going to use mean, and missing value will be considered as nan. So you can also change the missing value to be considered as -1 instead. But here we have nan. So we will just do imp.fit. It's always nice to do it like this. Imp.fit and x underscore train. And here we can do imp.transform x underscore train, and similarly we save it here. Valid, sorry. And here we need to replace the columns, xtrain dot columns. This is not required for this exercise, but anyways we are doing it. Xvalid dot columns. Okay. Imp dot fit x underscore train, imp dot transform x underscore train. Okay, it's saying me. Okay, so something has happened. Maybe we should make a copy. We should have made a copy. So I will just say x underscore tmp, x underscore train underscore tmp is x underscore train dot copy. So it changed the data set when it did the fit. And x, that's why you should do the copy, x underscore valid. So now I have to run a lot of things again. So let's restart the cell outputs and run a few things again. No problem, it runs fast, so that's fine. Okay, drop column with missing values. This we did, this we did, and now we are at imputation. Okay, so now instead of xtrain, I will just write xtrain imp, and xvalid imp. Okay, and let's see. What is my training data, or why is it changing my training data? Okay, so the error is not in xtrain, but it is in imputed xtrain, it seems. So my imputed xtrain is not a data frame, so it doesn't have dot columns in it, but we don't have to worry about it. If you are worried, let's fix it. So we can do imputed xtrain equal to pd.dataframe. We create a new data frame from imputed xtrain, and columns equal to x underscore train dot columns. So instead of imputing, instead of like doing this way, we have to create a data frame. So don't worry much about it. We don't even need this step. And now it's fine. Okay, so let's see what the MAE is after the imputation. So it's 18,000. So the previous one was 17,800, this is 18,000, so this is not an improvement. So you compare the MAE, yeah, the result surprises you, yeah, because it depends on your data set, and you have to try these different approaches. So now we generate the test predictions. So use an Excel code to preprocess the training and validation final train X. You can use any approach of your choosing here and generate the final X train and Y train hash. Okay. In order for this step to be more, you only need to ensure that the preprocessed data frames have the same number of columns. The preprocessed data frames have no missing values, and final X train and Y train have the same number of rows. Final X valid have the same number of rows. Okay. So can we just write X train and X underscore valid? So final X train is still contained missing values. Okay, fine. Okay. So like it's any approach that you can take. So we just take this approach and we change here strategy to mean. So we have X imputed, we have X train, we have X valid, and here this can go here and this can go here, and I think that should be it, right? So yeah, we just change the strategy to median, and yeah, that's it. And now we see how it performs on the final data set. So with median, it performed better, 17791. Okay, what was the best one? 178. So yeah, with the median strategy, we get a better score. Oh my God. Okay, so now we have the final X test, and that should be preprocessed the same way. So we have X tests from before, right? So X underscore test. So what we are going to do here is we are going to we don't need this, so we will only need this one. So final X test X underscore test, and preds will be, what was the name of the model? Model dot predict and final underscore X underscore test. Final X test is not a pandas data frame. Okay, it expects to be a pandas data frame. No problem. We can make it a pandas data frame. So here we take final X test, pd.data frame, final X test. Columns will be same as the training or validation columns. Okay, and you are done. And now it says you can also submit and test your results. So let's test our results since we have been doing that. Download and save the file, and let's go to the competition, submit predictions. So there is one more way of doing imputation that I will talk about like very shortly now. But let's first submit this. So we submit this one, and let's see what score we get. Okay, so we got 16619, 16619, which is still not better than what we had yesterday. Yay. Okay, but yeah, we learned something new. So now one more way of doing imputation, which is an advanced way and that has not been talked about in this tutorial, is to use a model to do the imputation for you, right? Very excited. So let's say you have a data set that looks like this, and you have a bunch of features, and you do have a target variable, right? Y, and this is your X. This is F1, F2, F3, F4, F5, and so on. And let's say some columns have missing values. So let's say F4 has some missing values and F6 has some missing values. A simple way would be to just do mean, as I mentioned before, mean, mean. Another way would be to do a machine learning model now. We ignore this Y for now. And we build a machine learning model on all the features which don't have missing values. Okay. Or we can also, so let's say the model one would be 6, F7, F8. Okay, so you have 8 features. F4 and F6 have missing values. So model 1 features F1 to F3. Then you have F5 and you do imputation and mean imputation for F6, let's say, and F7 and F8. F7, F8. So these are your features for model 1, and your target for model 1 will be F4. So now you train on all the rows of F4 which do not have a missing value to predict from your model what the missing value is. So this is one way. Another way would be to also ignore F6 and just remove all columns with missing values and then try to predict F4 and F6. So this will be model 2. Um, and in this way, so what you're doing actually, you're training a model to predict the missing values. Then you're using that model to impute missing values in validation and test set. And you are then making another model for your actual target variable. So this is one last way. It's very interesting way. You should implement that. And if you do implement that, post a link in comments and I will make it pinned comment. And that's it for today's video. I hope you like it. And if you do, click on the like button, do subscribe, tell your friends about it. And thank you very much. And goodbye.